In this tutorial, we're going to take a look at how we can use the PLM package in R to isolate fixed and random effects for a particular model. So usually when we work with data, we work with either cross-sectional or time series data. Cross-sectional where we're collecting all of our data at a specific point in time, and time series data where our data differs across time periods. Now, it can sometimes be the case that we encounter what's called panel data, which is a mixture of cross-sectional and time series data. And running a standard linear regression often doesn't account for the fact that these two types of data are being intermixed, and so we need a special way of being able to handle this type of data. So we're going to use the PLM library to be able to do this. So firstly, let's load our data set. And here we have a data set of internet usage per week by different customers. So we have 33 weeks of data, and we have 3 different companies, company A, company B, and company C. And what we want to do here is we want to isolate usage patterns both over time and by company. So we might find, for example, that usage tends to be higher during certain weeks than others, and we might also find that usage tends to be higher or lower across certain companies. So that could be due to pricing effects or data caps, etc. So we want to be able to isolate the effects of all these things. So let's go ahead and load our PLM library. And we're going to run 2 different regressions. So you can see here that we have usage as our dependent variable. We have income, hours of video, web pages, gender, and age as our independent variables. And we're going to be running the within model to account for fixed effects and the random model to account for random effects. So we'll run these 2, and let's get a summary. So when we look at the within model that's accounting for fixed effects, you can see that, like we would with a standard linear regression, we have our regression output indicating our estimates and also the significance of those estimates, as well as our R-squared. And if we run this for random effects, you can see that we have our estimates and our significance readings as well. You can see that certain variables that weren't deemed significant in the fixed effects model are being deemed significant in the random effects model. So we'd like to investigate more why this is and try and isolate the causes. So what we want to do is we want to estimate the effect of time on internet usage. So we're going to take our fixed effects model and we're going to run fixef to be able to determine this. So I'll just make this a bit bigger so you can see. And you can see that we have our estimates, we have our t-statistics, and for week 10 and week 33, we see that we have significance at the 10% level. So if we open up our data set, let's take a closer look at what's going on here. So I'm going to sort this by week. And if we go to week 10, you can see that the levels of usage across all 3 companies for week 10 is quite a bit higher than the average across all other weeks. So it indicates that usage in this week is particularly high. Maybe a new movie has been released or something that is drawing people to use the internet more often than usual. And if we go down to week 33, you can see that usage across the 3 companies is less than usual. So maybe people are going on holiday, maybe there's a popular concert in their town or something that's causing people to not use the internet as often. But the point is, you can see that the effect of lower internet usage is being based on time rather than being endemic to a specific company. Now, let's have a look at isolating the effect of time. So we want to isolate the fact that usage will differ across time, and we want to see what is usage for each provider, A, B, and C. So when we run this, you can see that we have a particularly negative value for company C. So isolating for the effect of time, this indicates that usage for company C is less than it would be for company A and B. Now again, as I mentioned, this could be due to various reasons. It could be due to pricing, it could be due to data caps offered by the provider, etc. And what we're going to do is we're going to firstly get the mean usage for each three companies. So you can see that in megabytes, the average usage for A is over 11,000 megabytes, and for C it's just over 6,000 megabytes. So we can see that the usage for C is lower than the other two. And it can help us to understand this intuitively if we plot this. So this is usage for C, so we can see that on the whole it tends to be low, but it spikes at certain time intervals. Whereas for B and A, we can see that we have spikes much more frequently. So what we've done is we've isolated the effect of time to show that usage for company C tends to be lower than for A and B. So in this tutorial, you've been introduced to the PLM library in R and how we can use this library to generate fixed and random effects for a particular model. Many thanks for watching, and feel free to reach out to me if you have any questions on what I've covered.